Okay, I'm going to do the two calculus parts to do with parametric equations as well. So today we'll do differentiation, tomorrow I'll show you integration. They're strictly not that bad. It looks a little horrible to think about first. We've got two equations and we want to find out what the gradient of it is. Now, if we remember that the gradient is given by dy dx, we know from what we've been doing with before that we can actually find out what dx dt is, and we can find dy dt. So using those, we can actually find, using a version of the chain rule, we can actually find what dy dx is. We do it by using dy dt. We want dt dx, and we remember, yes, dt dx is 1 over dx dt. So what we're going to do is differentiate the x part, differentiate the y, and the y becomes the numerator, the dx becomes the denominator. And that will tell me the gradient function in terms of y in terms of x. Okay? So, sorry, not in terms of x, in terms of a point t. Sorry, in terms of t, the value t. So let's do dx dt. And we get 3t squared plus 1. dy dt is 2t and no value. So when we put this into our equation, we want dy dx, we do dy dt and divide it by 3t squared plus 1. And this actually means that we can actually then calculate at various points what the gradient is. So they're going to say what's the value when at point P, which is when t equals 0. Not 0, equals 2. So when t equals 2, what's my gradient going to be? So we put it into the equation, dy dx, and we get 2 times 2 all over 3 times 2 squared plus 1, which is 4 over 13 is the gradient. Now, beyond that, so I can tell from the graph we're looking somewhere in this point here, over here. I'd like to actually be able to show it on the graph as well. So let's put in the x-coordinate for t. So x for 2. And that is going to be 8 plus 2 is 10. It's all the way out here over 10. It's not on my graph. When x equals 10, that's where we've got the gradient 4 over 3. We can also try and work out where. So other questions that might come across are things like find out when is the gradient of this function a half. So when is the slope positive 1 half? So we say dy dx is equal to a half, which is equal to my function 2t plus 3t squared plus 1. And we're trying to rearrange this so that we get an equation. So we've got 3t squared plus 1 equals 4t. 3t squared, bring the t back to the other side, minus 4t, add on 1, equals 0. Factorising it, I'm pretty certain it will factorise to 3t, t, we want 1, 1, both the same size, minus 3t, minus t gives me minus 4t equals 0. So we've got a position when t equals 1/3 and when t equals 1. using each value, we can find out what the x coordinates and the points are. So when using the values we've got, let's say x of t is 1/3 is t cubed plus 1/3 cubed plus 1/3. So put in the 1/3 and store it as a value. And so shift and store into a variable. We'll call it A. The reason I'm doing this is because I need to do this again in a moment. So we do alpha A cubed plus alpha A, and we get 3707 or 10/27. So that's just under 0.4. So it's saying that is a gradient of 1/2. And when we try x is t is 1, we get 1 cubed plus 1, which is 2, and it says that there's another point here where it's 1/2, which suggests to me that there is a slightly steeper gradient in between, and then it changes going between these 2 points. So there's 1 point, there's another point, and strictly they are parallel, and that's one thing you can find from them. The reason I didn't find out where's the slope 0, because when you do find out when the dy dx is equal to 0, it's fairly trivial for this one. So flat, you get 2t equals 3t squared plus 1, multiply across and we get 2t equals 0, so t equals 0, which leads to x of 0 is 0 cubed plus 0, and it gives us this 0 place, and y of 0 is 0 squared plus 1, and it gives me the 0, 1 point, so it tells me that's flat. That's the point, and one thing it does mean though is there is only one place it's flat. This goes off, tends off towards flattening off, but it is not actually flat. So that's the first differential one. And I'll do the trig example as well. So let's just put that one. This is example chapter 6.5. And we'll do the example number 2 as well. Give me a moment, so I'll sort out the graph for it as well. Okay, so the second example in chapter 5 on differentiation. For this chapter, this is section 1, is about an oval, and the equation they give you is defined as sine first. So let's just put that in the middle there so we know what we're looking towards. So we get told x is in terms of 3 sine theta, y is 5 cos theta. Should be able to read those. There's my 3 across, there's my 5, so the radii in the 2 perpendicular axes are given by these. Strictly speaking, we're saying that we're between 0 and 2 pi. And they want to find out about the normal. Well, first of all, let's find out about some other points, and then we'll talk about the example they're doing. So the first part is we need the gradient of this line. So what's dx dt? Now also dx d theta. So we differentiate that and we get 3 cos theta, differentiate the y dx, and we get minus 5 sine theta. So my function for dy dx, the gradient in terms of an angle theta, is the y part, dy dx, then divide the theta, and then divided by the dx d theta, so that we've got d theta dx. Okay, so there's my my differential. So we can actually say things like, where is the slope 1? And where the slope is 1, we actually put in y at 1 equals 1 minus 5. Okay, so we're now trying to put in the cos theta divided by 5 sine theta, sorry. And that's cos theta. Flip the numbers over and we get minus 3 over 5 is equal to tan of theta. So tan theta is any value where the arctan is minus 3 over 5. So we need to find those values using a calculator. Shift 3 divided by 5, and then shift tan of the answer. And it tells me and change mode to radians. Go back up and do it again. So the first angle, theta, first one is at minus 0.54. If we remember tangents, I've got a negative 0.54. So there's 1 on the negative 1, and then we add or subtract pi's to it. So let's add pi. Minus 3 at 5.34. Add on, shift pi. Gives me 2.601. And add on again, because we're between 0 and 2 pi, remember. So we need another one. So add on another pi, and that's 5.743. So these are the two answers that are going to give me answers in here. Find the value of x. So x equals 3 times the sine of my angle, 2.601. 3 times the sine of 2.601. And that's the number 1.54. So if I go to 1.54, which is about here, we've got, that's a negative 1. Oh, hang on. Yeah, I haven't done the y values yet. That's why. We've got a 1.5 value. And if we try the second one, 3 sine 5.743. 3 times sine 5.743. Hopefully that should be a negative value of the same amount. Yep, minus 1.54. And then to choose which value it is, we need to do the y, whether it's the top or the bottom. So y equals 5 cos of the angle. Of 2.601 and 5 cos 5.743. 5 times cos 2.601 is minus 4.287. So about minus 4.3, which is about here. So that's 1.54, and minus 4.2 is one coordinate. And when I do the other one, why did it disappear over there? Delete. 5.743. And this one gives me a positive 4.287. So that was our first solution, and our second solution is plus 4.3 up here. That's our 2 points with a positive gradient of 1. Okay, and that's them shown on that graph. They ask you to find the normal when theta equals pi over 6. So theta equals pi over 6. We want to find out what the gradient is again. So now we want dy dx of minus 5 sine theta divided by 3 cos pi over 6. They do the numbers for us, so it's minus 5 over 2, minus 5 times a half. Notice the times should be in there because otherwise it gets misread. And 3 times the square root of 3 over 2, which is minus 5, 3 over root 3. But they wanted the normal. And if you remember, the normal is at right angles. So we've got our gradient m. The normal makes a right angle, and the normal is minus 1 over m, or m times m normal is minus 1. So the normal has a gradient of minus 3 root 3 over 5. Over 5 that should be, sorry. Okay, so that's the differentiation, ways you can use it. What else were they asking for in there then? They're asking for something else. Oh, they want to find the coordinates as well. So now we've got our gradient, put the values in. Let's see, actually find the equation, they say. Oh, they said find the equation. So you've got your gradient, which is the normal. The next part is to find out what x is at pi over 6, which is the 3/2. So it's 3 times sine pi over 6. Yeah. And y at pi over 6 is equal to minus 5 times the cos of pi over 6, which is 5 root 3 over 2 from that one. And despite what they go off and do with their equation, remember you don't have to simplify equations overly unless you need to. So what you can have is, remember there's the gradient, definition of a gradient is y over the difference between 2 y points minus 2 x points. So a common way to rewrite this is you can say y minus y0 is equal to your gradient times x minus x0. They go off and rearrange that and simplify things left, right and centre. You might want to do it, but you can substitute in the y0 is this value of a point you know. 5 root 3 over 2 is equal to our gradient for the normal, which is minus 3 root 3 over 5, x minus 3 over 2. Now that is actually an equation for the line. What they've done then is they've actually gone on and simplified it. So combine terms, bring them round. I think they said they're multiplying by 5. So to do that one, I think I'd probably be tempted to multiply through by 10 myself. So it's 10y minus 25 root 3 is equal to minus 6 root 3. That's by multiplying by 5, and I'm going to multiply this by 2. 2x minus 3. And bring the values around and combine them. So we get 10y equals minus 12 root 3x, add on. So that add on 18 root 3 minus 25 root 3. 12 doesn't seem to be coming down. Oh, they divide through by 2, don't they? Still doesn't look nice. 8, 15, 5 5s is 25. Root 3. I spotted my mistake. I've got the sign wrong back here. Yeah, I forgot the normal changes the sign as well. So that's plus, that's plus, that's plus. So we now get positive 12x minus 8x, add on 25. Still not giving me the numbers they're looking for though. When I was multiplying by 10, this cancels 5, and I multiplied the 2 into here. So that should be multiplied by 5 to cancel, and that bit gets the multiplied by 2. So we should have 3 there. This is 3 root 3. 6 root 3 and minus 9 simplifies to 6 root 3x plus 16 root 3, and then they divided through by 2. 5y is 3 root 3x plus 8 root 3. Okay, that's how you get down to their answer. Only need to worry about that if they turn around and say, give the equation in an exact form, using exact values. They may ask you to simplify. So this is simplified, which is getting it into a single line to there. And then this is as simply as possible, or exactly. So look for those words in the exam questions.